So on our notes from last week, from the first time part 1, I'm going to write that small numbers. This is the method we want to use for small numbers. So 18, I know, is not tiny, but we can do the math pretty easily for like numbers like 18 and 30. But we're going to be working with really big numbers, like in the hundreds for some. And there's a different strategy. So I'm going to put big numbers for today's lesson. Okay, so on last week's, this was the strategy we'll use for when we were trying to find the GCF of smaller numbers. And now we're working with bigger numbers. Okay? Okay, so part 2. If your book is open, I'm going to be looking on page 100. What's up, Tice? Okay. Okay. So, today we're going to use factor trees. To help us find the GCF. And this is what, even if the numbers are small-ish, this is what you're going to use when you don't know all the factors, right? Because when we're trying to find, like 12, the old way, we have to know all of the factors. So we have to know 1 and 12, 2 and 6. It's a good remember fact, right? 3 and 4. You have to know all of them. So if you don't know all the factors of the number, it can be tricky. So, 4 and 6, sorry. So today, our first example is going to be to combine, or to find the GCF of 3 numbers. So, find GCF of 18, 27, and 36. Okay, and we're not going to use this old way. Scratch that out. We're not going to use that. That's for small numbers, and these are medium numbers. So we're going to use factor trees today. Okay, so if I start with 18, give me any 2 numbers that go into 18.
6 and 3.
That's what I was thinking. Stole it right out of my brain. So 3 and 6. Are either of those prime? Which one? Show me on your hand. Circle it. Branch out the other one. What goes into 6?
2 and 3.
2 and 3. Which one is prime?
Both.
Yeah, nice. Okay, so for 18 on the bottom, I'm going to list 2 times 3 times 3. I'm not going to use any exponents or powers. This is not the place to brag about how smart you are, okay? We're going to just put everything that we got, every answer. Okay. Now we're going to do 27. Give me 2 numbers that go into 27. Any 2 numbers.
I think they 3
Times?
3 times 9.
Good. I knew you'd get there. And 3, you already told me is prime, so I'm going to circle it right off the bat. And then 9 is not, so I'm going to branch it out.
3 times 3.
And which one of those is prime? So for 27, I'm going to put it right underneath 18. And I'm going to put its factors. So 3 times 3 times 3. Again, I'm not going to use any powers or exponents. Okay, and then the last one, 36. Any 2 numbers that go into 36? You know.
6 times 6.
6 and 6. And neither of those are prime. So we factor them down and we leave all of the primes. So 36 is my final number to put underneath. And my factors for 36, I'm going to put them in number order. 2 times 2, there were 2 of them. And then 3 times 3, 2 of those as well. Is everybody with me?
Yeah.
Great. So if I was to make a list of steps, I'm going to factor tree, each number. Okay? Then, after we factor tree each number, we're going to write the factors I think I'm going to write list. List the factors. Okay, so step 1 is here. Step 2 is here. And then lastly, before we can finish, remember we're supposed to find the greatest common factor. So to do that, our next step is going to be circle list. List. Sorry, I changed my mind. That's why you should use pencil. List the factors, and then lastly we're going to circle all common factors. So any that they have in common. Okay, so that is going to be what I'm up against now. So, if I check for 18, my first number is 2. So I'm going to check, is there a 2 in 27? No. So that means the 2's are not going to be circled. They are not going to be included because they are not common. Okay? Are you guys with me? Okay, so now I'm going to move to the next number. The next number, I'm just starting with 18 because it's on top, is a 3. Do I have a 3, at least one 3 in 27? What about 36? Okay, so I'm gonna circle them, and they're not stacked very nice for me, but I'm gonna try and loop them in the same. Do you see how I kind of squiggled it? The first 3 in each row. I tried to circle all together. The first 3 in each row. Okay? Okay, so for my GCF, so far I have 1 3. They have 1 3 in common. Okay, I still have one more number in 18, Joaquin. I have one more number, and it's a 3. So now I'm going to check, is it common? So I have 1 more 3 in 18, 2 more 3s in 27, and 1 more 3 in 36. So is it common? Do they all have it?
Yes.
They do. So I'm going to circle it as best I can. It's kind of a squiggly circle. There's 1 3 in each group. So there are 2 3s that are common, which means GCF is equal to 9. So our very last step is to multiply the common factors. Okay, I'm not going to write the steps again, but we are going to do a couple more problems. How do we feel about this?
It's good, but sometimes it's harder for me because I need to know every single factor for the same.
Sure, sure. I mean, it's going to take some practice. It's going to take a little practice, but I know you can do it. Okay? Okay. So the GCF for 18, 27, and 36 is 9. That is their greatest common factor. Let's do another one. Let's do 36, 60, and 84. Big numbers. I don't know all the factors of 84. Okay? For this second example, I can start with 36. The last time we did 36, we did 6 and 6. So let's pick 2 numbers different from 6 times 6 that go into 36.
12 and 3.
12 and 3. Are either of those prime?
No.
Yes, 3 is.
Oh yeah, 3 is.
3, so we circle it. And 12, we break down. We factor it down. What goes into 12?
4 and 3.
In 2.
I'm going to go with 6 and 2 because I was looking at Reese. 2 is prime. 6 is 2 and 3. So for 36, we still end up with 2 2s and 2 3s. Let's stop with the noises. Thank you. Okay, 60 is the next one. 60. Paul, what 2 numbers go into 60? Any 2.
10 and 6.
Yep, that's what I would pick also. 10 and 6. 2 and 3 go into 6 and they're both prime, right? 'Cause we just did 6. How about 10?
Wait, no.
What goes into 10?
5,
And?
2,
Good. And which one of those are prime?
2, and 5.
Yeah, they both are. So for 60, I'm going to list that underneath. I have 2 2s, and I have 1 3, and I have 1 5. Again, no powers, right? We're not using any powers. Can you guys see that okay up there?
Yeah.
Great. All right, 84. So using my rules in that distributive or the divisibility book, what can you tell me about 84? Anything? What can you tell me?
You know 2 goes in.
2 goes into it. Why?
Because anything that's even,
Yeah,
2 goes
perfect. So I can divide it by 2. What other number goes into it? What other number can I check really easy? What number? Anyone?
12.
Joaquin? So 12 goes into it, but which one can I check for my divisibility rules?
16.
Hudson?
21.
3. You guys are all doing harder math than I am, okay? So 8 plus 4, right? 8 plus 4. Shh. 8 plus 4 is 12. And 3 goes into 12, so 3 also goes into 84. Okay? So the first one you gave me was 2. So that's what I'm going to do off to the side. I'm going to do 84 divided by 2. 2 goes into 8. 4 times even. And 2 goes into 4 2 times even. So I get 2 and 42. So I'm going to circle the 2 because it's prime. And now I have 42. What 2 numbers go into 42? Max?
6 and 7.
6 and 7. Are either of those prime?
7 is.
7 is. And for 6, we've done that several times already today, so 2 and 3. And when I list it, 2 times 2 times 3 times 7. So now I've done step 1, factor tree. I've done the second step. I listed them. Now I need to circle all the common factors. What do we see that's common in this list? Oh, good. A lot of you are feeling confident about this. Mia Dove, what do you got? 2. If I start with 36, the first one, right on top I have a 2. And when I check, all 3 of them have a 2. So now my circle isn't so weird in this one, right? It's going to be prettier. Okay, so then I go to the second column.
2.
2. I have 2 again in all 3, so I get to circle them. Then I go to the next column.
3.
3 is common for all 3, so I get to circle it. And now I have the last column. Is anything common?
No.
Womp womp. I was on a roll. So for my GCF, my last step, I'm going to multiply the common factors. My common factors are 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is 12. The GCF for 36, 60, and 84 is 12. Are you guys ready to try one? Yes. If you have your whiteboards, you can do it on your whiteboards, or you can do it in your notes if you don't. Find the GCF of 48, 80, and 128. Okay? You've got this.